Hello and welcome to this new video in the Learn C Sharp series. Today we're going to be covering value types and reference types, how they're kind of handled in memory, and when to use them and when not to use different types. If you're new here, I have to learn C Sharp by this summer for an upcoming internship. And at the moment, I don't really know much. And I find the best way of learning is actually through teaching. So here I've created this series for both of us to really learn. In this series, we'll be following C Sharp 12 in a nutshell, which you can go find over on O'Reilly Media. With that out of the way, let's get right into it. Now, when I first started programming, I didn't really know what a reference type or a value type was. In Java, we have primitive types and the reference types, but again, I just programmed to make programs. I didn't really care for what was going on under the hood. What it boils down to is that value types are really the basic building blocks of any program. We can represent a string, which is a reference type, through a sequence of characters, in which characters are the value type. We also have Boolean. We can have our structs, our enums. These are all examples of a value type. If you ever question yourself on whether something is a value type or a reference type, value types are typically not imported. A value type is the actual content that it's holding. We're not going through another pointer to access some kind of memory area. So if I have a character called C and it's equivalent to the character A, when I go to access C, we are directly going to A. And for a fun fact, a character over in C Sharp is actually just a 2-byte space in memory. So if we go ahead and do a system.console.writeLine and we print the size of what a character is, we can just do size of and char. We're gonna get 2 printed out to the console here, so we get 2. And then if we, let's say that we change this to a bool, not in all caps though, and we're gonna assign it to false. If we go ahead and print the size of a bool too, we're probably going to get 1. It's just 1 byte in memory, but actually a boolean is really 1 bit. So if we have 1 boolean that we're storing, which is a bit, and it's taking up a whole entire byte in memory, and a byte is 8 bits, we have 7 extra bits of remaining space, which can be a problem. In contrast to the class concept, we can make structs instead. So let's kind of think about something that we can model as a struct. So we have a water bottle. Every water bottle has some sort of diameter, maybe a color, a brand. So let's go ahead and model that as a struct. So we just need to say struct water bottle and then open the braces. And then here is where we can define what defines a water bottle. We can just have int diameter, and then what else? We can just go ahead and do int volume. And so every water bottle that we're going to make in this program is just going to have a diameter and a volume, which these are also being made up of value types. Let's go ahead and make this struct public and then create a quick constructor for it too. So remember, to create a constructor for either a class or a struct, we just need to say public and then the name of the class and then give it whatever it'll take as argument. So a diameter and then a volume. And then inside of the constructor, we just assign those. So we can say this dot diameter is equal to the diameter that we were passed in as an argument. And then the same exact thing for the volume. So this dot volume is equal to the volume we were passed in. And so now up here, we can create a new water bottle instance. So we say what kind of type that we're creating, or instance, the instance is type. So water bottle, and then we're just going to name it WB1. And it's going to be equal to a new water bottle given the constructor, and we're going to pass in, let's say the diameter of my water bottle is 2. We haven't defined any kind of units, but we'll just go ahead and say 2, and its volume is maybe 24 ounces or something. So here we have a water bottle. And what if we wanted to make a second water bottle? Well, let's go ahead and do something very similar. Let's just copy what we have on line 7, put it on line 8, and then name this WB2. Instead, this water bottle is going to have a diameter of, let's just say 4, and it holds 48 ounces of water. Now if we go ahead and print these out, let's just go ahead and do a system.console write line here, if I can spell correctly, and I do wb1.volume, which we're going to have an issue here because the properties inside here are not public. So let's go ahead and change those two. So these are both public. If I print out wb1.volume, we're going to get a 2, and then let's go ahead and do the same thing for wb2, and let's just confirm that 2 and 4 are going in the correct bases. Oh, whoops, I'm doing volume. So I meant 24 and 48. Okay, so they have their respective volumes. But what if I wanted to create, or I wanted to assign WB2 to WB1? Well, let's go ahead and instead creating a new instance, do this instead. So here again, we're going to get 24 and 24. But what if I change WB2's volume to some other kind of number? Well, let's go ahead and go down here and do WB2.volume is equal to 0. Now, there's two answers to this. Either WB2 gets 0 and WB1 gets 0, or they're separate. Let's find out. As you can see, WB2 gets a volume of 0, but WB1's volume remained as 24. And this is because structs have independent storage. They're actually just, what's going on here is that WB2 is taking a copy of WB1 but storing it over in its own location. So any changes that happen in one struct will not reflect in another instance of that struct if we're assigning it to another one. So really, at the end of the day, structs are just copying from other structs into their own data space. In contrast to the value type, we have a reference type. Reference type is just holding onto a reference to a bunch of other data elsewhere in memory. Typically, if we think about the stack, which is running in our program, we have a pointer that's sitting in the stack that's pointing over somewhere in the heap, which is dynamically allocated. Our stack is something that we want to keep fixed size, or at least all the pointers in there. But if we have different kinds of classes or arrays and strings placed in our stack, we won't really have a way to define, okay, this pointer is going to be this long, or this section of memory that we're reading is this long, and so on and so forth. So instead, if we just have a pointer to another place in memory that is specifically delegated to handling different amounts of data, this is how a reference type really works. And so again, some examples of this would be the class, an array, strings, and any other kind of custom data types that you're defining. Now, as we've already discussed, reference types can be drastically different from their counterparts in value. Let's go back to our water bottle example, but instead of having it as a struct, we have it as a class. So again, here's the water bottle class. Everything's public, so we can access everything. Let's create another water bottle instance. So water bottle WB1 is equal to new water bottle, where we pass in 1, and let's just go with 24 this time. And so if we were to print out WB1's volume, we would get 24. What if I wanted to create another instance of water bottle but assign it to WB1? So we do water bottle WB2 is equal to WB1, which already exists. Now let's go ahead and write our print statements of what's going to happen here. So system.console.writeLine, and we're going to print out WB1, not XB1, WB1 volume. And if I can spell correctly, that would be great. So WB1 volume, and then let's go ahead, copy this, paste, and let's change that to WB2. Okay, so here we're going to get 24 and 24. I mean, just like how we had it with the struct. But instead, if we were to do WB2.volume and we set it equal to 0, we're going to see something different. All of a sudden, when we print this out, both WB1 and WB2 have had their volumes changed, despite WB2 only one that changed volume. What's going on here is when WB1 is copied to WB2, we're only copying the reference and none of the data. So really, we just have two references, WB1 and WB2, in which WB2 copies WB1's reference to the same place in memory. So really, these are two references pointing to one location and sharing the same data. So any two references that are sharing the same data location are going to have the same changes reflected. Unlike structs, we can assign instances of a class to a null value. So if I were to do WB2.volume is equal to 0, we're going to get an error. All of a sudden we get a null reference exception, because what's going on here is that WB2 has no reference. It's just null, which is kind of non-existent. So if we're trying to access a non-existent volume attribute, we're going to get some sort of error that makes no sense. And so you can run into the null reference exception in C#. And that's it for the video. Thanks for watching. If you actually learned something or found this to be interesting, consider subscribing and liking the video. There are plenty more C# videos to come soon, and I'll see you in the next one.